Imagine a vast network, pulsating with energy, connecting cities and towns with the power of civilization. At the heart of this grid lie transformers. These unsung heroes shape the electricity flowing through the grid. Power transformers step up voltage for transmission and step it down for safe distribution. Without them, our modern world would grind to a halt. Imagine a world shrouded in darkness, the hum of appliances silenced. This is the potential consequence of neglecting transformer testing. Regular testing is crucial to prevent catastrophic failures that can disrupt power supply and lead to costly repairs or replacements. Testing provides a window into a transformer's health, allowing us to detect and address issues before they escalate. Here we create a series of video for various tests performed in power transformer, ensuring the perfect healthy condition. This may become a loner video, but we separate it to different parts.
In this video series, we learn all about the power transformer testing. Take a notebook and pen and synchronize yourself with us. First of all, we must know that the type of various tests performed in the power transformer to check the healthy condition. 1. Voltage ratio test. 2. Phase displacement test. 3. Insulation resistance (IR) test and polarization index (PI) test. 4. Winding resistance test. 5. Measurement of no-load loss and current at LV rated voltage 11 kV. 6. Measurement of short-circuit impedance and load loss. 7. Separate source AC withstand voltage test, applied voltage test. 8. Induced AC voltage test. 9. Temperature rise test. 10. Measurement of no-load loss and current for each phase. 11. Measurement of short-circuit impedance and load loss, repeated for each tap position. These tests collectively ensure the transformer's operational safety, efficiency, and longevity.
Now think about that. What are the purpose of these tests? If we understand the purpose and significant, then analysis and judgment in the result will become easy. So, here we will see significance of various tests one by one. 1. Voltage ratio test, to verify the transformer's turn ratio and ensure proper voltage transformation. 2. Phase displacement test, to confirm the correct phase relationship and vector group configuration. 3. Insulation resistance and polarization index test, to assess the condition of insulation and detect moisture or contamination. 4. Winding resistance test, to check the uniformity and continuity of windings and identify issues like loose connections. 5. Measurement of no-load loss and current, to measure iron losses under no-load conditions and assess core efficiency. 6. Measurement of short-circuit impedance and load loss, to determine copper losses, impedance, and voltage regulation during load conditions. 7. Separate source AC withstand voltage test, to test the insulation strength between windings and earth under high voltage. 8. Induced AC voltage test, to ensure insulation strength between turns and phases by applying high voltage at higher frequency. 9. Temperature rise test, to evaluate the transformer's thermal performance under rated load conditions. 10. Measurement of no-load loss and current for each phase, to detect phase imbalance or core saturation by measuring individual phase losses and currents. 11. Measurement of short-circuit impedance and load loss, each tap position to confirm consistent impedance and load loss across all tap positions. Before we learn how to conduct each test, we should know the correct nomenclature of HV and LV windings. Generally, we denote the HV windings with 1U, 1V and 1W since it is delta connected, and the LV winding denote as to U to V to W and 2N, as it is star connected. Let's start one by one. First is voltage ratio test. The main purpose of this test is to identify the proper voltage transformation from HV to LV. A 3-phase 440 volt AC supply is given to HV side, and the phase-to-phase and phase-to-neutral voltage measured from LV side. This voltage is measured by ratio meter as shown in picture. This test is performed in all taps of power transformer and the voltage is measured as per the table shown. Take a pause and have a screenshot of this table for future reference. The result must satisfy the reference value mentioned in the table. Any deviation in the reference value means there is possible damage of turns or incorrect connections. The major deviation means the turns are shorted or wrong tap changer setting. Now, move on to the second test performed on the power transformer, that is, phase displacement test. The purpose of this test to confirm the correct phase relationship and vector group configuration. This is mainly used in parallel operation of power transformer. As we all know that, in our substation there is DYN11 type power transformer installed. The primary is delta connected whereas the secondary is star connected. Remember, this test is performed in normal tap position. Now, short the 1 HV and 1 LV terminal, that is 1 U and 2 U is shorted. Now, apply a 3-phase 440 volt supply to the primary side of the transformer and measure the voltage as per the table given. In this table, we measure the voltage between primary and secondary winding in normal tap position. The measured voltage of previous table must satisfy the condition mentioned in the table shown. Any deviation from the condition mentioned in the table indicated that internal windings connection or core magnetization issue is there. So, engineers, in part 1, we learned about the two major tests, the voltage ratio test and the phase displacement test. In the second part of this video, we will explore the other tests mentioned. If you'd like to see the second part sooner or have any doubts, please feel free to comment below.